So, welcome back. Welcome back, Abafundi, Sanbonani. Today we're going to continue our study of functions, and we are going to look at specifically classifying functions according to type. Okay, so far we've talked about functions and non-functions, but in fact, all functions can be divided into two different types. We've got functions that are one-to-one. An example would be y equals 2x plus 3. When we put in an x value, we only get one y value out. Okay, so it's one-to-one. Right, the next type is what we call many-to-one. And here, when we put in an x value, we only get one y value out, but it is possible to put different x values in and get the same value, y value out. For example, here, if we put in -2, we get 4 out. But also, if we put 2 in, we get 4 out. This one is called a many-to-one function, all right? Many-to-one, whereas the other one is called a one-to-one function. One input, one output. Many inputs to one output. Another classic example of a many-to-one function, if we think of which we've come across before, is y equals sine x. So, for example, there are thousands, in fact, infinitely many numbers that we can put in order to get one out. All right. Sine of 90 is one. Sine of 450 is one. Sine of 810 is one. Every time we add 360 degrees, we just get another place where sine is one. Right. Don't confuse that with a one-to-many thing, which is a non-function. This is not a function, this one over here, because we're putting in one input and getting two outputs. An example would be something like the positive or the negative square root of x. You put 9 in, you get -3 out, and you get 3 out. Okay, so let's look. Here's an example of each. Both of these are functions. Remember, the test for a function is, can we pass a horizontal line over the graph without it touching at more than one point at a time? Right, and there it is. Yes, both of these are functions. Okay, however, but kodwa, right? This one, we can also pass a horizontal line over this function, and it never cuts at more, the one on the left, okay? It never cuts at more than one point at a time, right? The one on the left never cuts the horizontal line at more than one point at a time. The one on the right, okay, it actually does. It actually cuts at more than one point at a time. Right, so we can see there, it cuts twice. That is a many-to-one function. Right, let's carry on and have a look. What we want you to do now, we're going to ask you to pause the video briefly, and we're going to ask you to check whether these functions are one-to-one, many-to-one, or in fact, if they're not functions at all. All right, so take a look at this and see. And just before we do that, quick reminder, if it passes a vertical line test, it is a function. If it passes a horizontal line test, it's a one-to-one function. If it fails the horizontal line test, right, then it is a many-to-one function. But if it fails the vertical line test, it's a non-function. Right, have a go and see how you get on. Right, so this first one, you may be kind of unsure, but if we were to picture this as a graph in our heads, this is a parabola, right? It is a function, but in fact, it fails a horizontal line test. So it passes the vertical line test, it's a function. This is a many-to-one function. The next one, y equals cos x. Again, it's helpful if we could picture this in our heads, because cos x actually looks something like this. Right, not very well drawn. And in fact, my computer thought I was trying to rub something out, so it just decided to get rid of it. It wasn't very helpful. Okay, we'll have another go at that. like that. Okay, and so it carries on. This one is also many to 1. It passes the vertical line test, but it fails the horizontal line test. This one over here, not a function, non-function, because it, sorry, absolute nonsense. This one over here is also a many to 1 function, right? It has passed the vertical line test, and it has failed the horizontal line test. So it's a many to 1 function. I was actually looking at the next one. This one is a non-function. Non-function, it fails the vertical line test. Negative 2x plus 4, well, we hope that you can remember what that looks like. It's just a straight line with a downhill slope, negative gradient, okay? It is a 1 to 1 function. It passes both the horizontal, well, we do the vertical first, pass the vertical line test and the horizontal line test. 3 to the x minus 8, you may or may not remember what that looks like. It is in fact an exponential graph, and we're going to revise all these graphs, so don't worry, but it's actually been dropped down. It looks something like this. Okay, that's the basic shape of it. It also is 1 to 1. This next one is a hyperbola. It is also 1 to 1. It passes the vertical line test, so it is a function, but it failed, and so it also passes the horizontal line test, 1 to 1. This one is a function, it passes the vertical line test, but it would fail a horizontal line test somewhere over here. So in other words, this one is many to 1. Okay, right. Now, we're now getting into the real meat of this section, so really important that you concentrate carefully. We're going to talk about now about inverse functions. And the inverse of a function is the function which undoes the function. Okay, and we've actually come across these. We've come across them as we've solved equations. What's the undoing of adding 5 to a number? How would we undo that? If I had 6 and I added 5, I'd get to 11. What would take me back to 6? That's right, subtracting 5. So adding 5 and subtracting 5 are inverse functions of one another. We actually call them inverse functions, but so it's also okay if in your mind you think of them as undoing. What's the inverse of doubling a number? If we double a number, let's say, suppose we double 3 and we get 6. How do we get back to the 3? Yeah, doubling a number, halving it. The inverse of doubling a number is halving a number. What's the inverse or the undoing of squaring a number? It's square rooting a number. Square rooting. Okay. Now, let's look. We have a notation where we use the little -1 on the function name on f. All right. Now, this is not to be confused. Okay, and there is room for confusion here. I'm just going to write something over here. 2 to the -1, we hope you know, is 1 over 2. A variable to the -1 is 1 over a. But f to the -1 is not 1 over f. F to the -1 is the inverse of f. And we must make sure that we don't kind of confuse those things. Right, now, the thing with an inverse function and a function, they undo one another. Let's look at this. We've depicted it here as a machine, right? Let's pop 4 in here. If we pop 4 in here for x, wind the handle, what comes out? Well, 3 lots of 4 is 12, take away 2 is 10. Now, if we pop 10 into this inverse function, 10 plus 2, 12 divided by 3 is 4. This function undoes what that function did. Okay, does it make sense? Indeed, impela. It always makes sense. Okay, now let's look at going the other way. Let's put a number into here. All right, suppose I put 7 in here, and I put 7 into the inverse. 7 plus 2 is 9, divided by 3 is 3. Now let's put 3 into the function. 3 lots of 3 is 9 minus 2 is 7. Okay, so a function and its inverse always get us back to where we started. Doesn't matter which order we apply them in. And I'm just going to show you an example of this. If we square root 16, right, and then we square the answer, we square root 16 and then we square the answer, we get back to 16. Or if we take a number and we square root it, if we take a number and we square it, so let's take something like 3 and square it. Okay, what do we get? We get 9. If we now square root, we get 3. Okay, so really important. Doesn't matter which order you apply them in, a function and its inverse undo one another, leaving us with the original value. Okay, I've made the note here about don't confuse this with an exponent. On your calculator, you'll see that we've got a button, sign, and we've got undo sign, or the inverse of sign. Let's just pull that up and take a look at how that looks. So for example, if we take the sine of 30 degrees, we get a half. If we now go shift sign, undo sign of a half, we get 30 degrees. Okay. And that's how that button works. Right, now, because with an inverse, our x values, our inputs become outputs, and our outputs become inputs. A function and its inverse are always reflections of one another about the line y equals x. So for example, here's a point. Let's suppose that that point is 0, 3. So when we put 3 into the function, so when we put 0 into the function, we get 3 out. The inverse undoes that. So when we put 3 into the inverse, we get 0 out. And what you'll see is that, in fact, this point is actually reflected across here, as if this is a mirror. I will show you a sketch just now to help you understand this a bit better. Okay, let's look at another one over here. Suppose, and I'm just making up numbers here, but suppose this point over here, this looks like an exponential graph, okay? Suppose this was 2, 5. So when you put 2 into the function, you get 5 out. The point, if you swap that point around, 5, 2, when you put 5 into the inverse, you get 2 out, because the inverse undoes what the function does. Okay, and what you'll see again is a reflection across the line y equals x. This line over here, y equals x. Okay, and a function and its inverse are always reflections of one another around the line y equals x. Right, here's another one. And what you can see here is that we've actually got the function g, which is in blue, okay? And then we've got the inverse function in red, which is a dashed line. Just for interest, it's interesting here, but g is actually a function, if you notice, because it passes a vertical line test. It's a many to one function. Now think about many to one, all right? I think left and right are swapped over here. Many to one, all right? That becomes one to many when you inverse it. So in fact, the red graph is a non-function, but we will talk a little bit more about that. Let's show you a picture of what's actually happening here. Okay, so here we've got a function in blue and its inverse in red. I just want to show you kind of a couple of points here. You'll see we've got the point on this blue graph. We've got the point 2 and 0. Sorry, 0, 2. And if we flick that around, 2, 0. Okay, and what we should see is this reflection idea. Okay, let's just look at another point. Negative 2, 2. Flick that around to negative 2. 2, negative 2 lies on the red graph. Negative 2, 2 lies on the blue graph. If I was to drag the blue graph around, you'll see that the other one, because it's an inverse, it will be a mirror image and it will also drag around. Okay, so we can see, notice that if either of them crosses the line y equals x, think about this point over here. It looks like about 2, 2, 2, 2. Now, if you swap that around, you get the same point. And that's why that lies on both graphs. Okay, we will show you this sketch again later as we draw some more functions. But the important thing to understand for now is that a function and its inverse are always reflections around the line y equals x. Every single point swaps around. Look at the point, the turning point on the blue graph, negative 2, negative 1. Swap that around, negative 1, negative 2. Okay, right. So we're going to finish off there for today, and we will pick it up next time. We look forward to seeing you then.